capturing already. Sorry. Today we are going to be looking at few other questions on uniform motion. You know, in our last class we discussed the equation of motion. We were able to derive the 3 equations of motion. Now I promised you I'm going to solve few other questions. So we are going to look at one or more questions today so that you see how we manipulate those equations. So stay tuned. A body starts from rest and travels distances of 120, 300 and 180 meters in successive equal time intervals of 12 seconds. Let us begin to interpret it. We have body starts from rest. Let's say the point of rest of this body is A, and move. We have 3 successive intervals. We have first interval, let's say to B, then to C, then to D. So what the question is saying is that the first interval the body moved 120 meters, the second the body moved 300 meters, the third the body moved 180 meters, and at each interval the time is the same. So we have 12 seconds for every interval. 12 seconds, 12 seconds, even though their distances were not the same. So during each interval the body is uniformly accelerated, so there is a constant acceleration. Calculate the velocity of the body at the end of each successive time interval. So a body begins from here. We are looking for the final velocity of every interval because they said we should calculate the velocity at the end of each successive interval. You know, the question said that the body starts from rest. Initial velocity here, let us call it u1, is when a body is at rest, and then the body moved at this point. For the first interval, this point B is the final velocity. Let's call it v1. I said u stands for initial velocity, v stands for final velocity. So v1 is the final velocity for the first interval. But you know, this same point where the first interval ended is where the second interval began. So u2, let's call this u2 for the second interval. This point, that is the final velocity for the first interval, is the initial velocity for the second interval. Then at this point C, the second interval ends, and that becomes the final velocity for the second interval, and that same point is the initial velocity for the third interval. The velocity at that same point is the initial velocity for the third interval, and then the final velocity v3. So the question is expecting us to find v1, v2 and v3 because it says we should calculate the velocity of the body at the end of each successive time interval. So we are going to take it interval by interval. Remember I told you what you do is to list your parameters, list the 3 equations of motion, and begin to compare. So in the first interval we have a distance s of 120 meters. We have initial velocity because the body started from rest. At the point of rest there is no velocity because the body was not moving. So the initial velocity u1 is 0 meters per second, while the time is 12 seconds. While we are looking for the final velocity v1, that is what we are looking for. If you recall our equations of motion, equation 1 says v equals u plus at, equation 2 says s equals ut plus half at squared, while equation 3 says v squared equals u squared plus 2as. So what I said is that we look at our parameters and begin to compare. In the first equation, the v is unknown, is there, u is there, t is there, but a is not there. V is unknown, a is unknown. There are 2 things that we do not know in equation 1. You come to equation 2, s is here, u is here, T is here, V is not here. But if you look at this three equation 2, S is known, U is known, T is known, T is known. It's only A that is not known here. Remember, in the first equation we had 2 unknowns. The second equation we have just 1 unknown, that is A. In the third equation, V is unknown, U is known, A is unknown, S is known. We don't know V, we do not know A. We don't know V, we do not know A. So these two equations, we have 2 unknowns. But we're looking for V. We would have preferred this because this is just 1 unknown. But what the unknown here is A. There is no V here. So, but why don't we use this one that is having just 1 unknown to get the A? If we're able to get the A, we can now substitute either here or here to get our V that we are looking for. Instead of using these two that have 2 unknowns that we can solve simultaneously and still get what we want to get. So I will prefer to use equation 2, solve and get A, then substitute the A either in equation 1 or 3 to get our V. So let us do that. Okay, so if we do that, our S is 120 meters. 120 meter equals U is 0 meters per second, 0 meters per second, times T is 12 seconds, 12 seconds, plus half times A is unknown, times T, 12 seconds. So remember, this T is squared, so we're going to square this 12. So we have 120 meters is equal to 0 times 12 will be 0, so everything here is 0, plus half times A times 12 squared is 144, then second squared, you have second squared. So that is 120 meters is equal to A times 144 second squared over 2. So we can cross multiply or even divide this way. 2 can divide 144 to give us 72. So we have 120 meters is equal to A times 72 second squared. We divide both sides by 72 second squared. 72 second squared. 72 second squared will cancel 72 second squared here, so that A is equal to 120 over 72 is equal to what? 5 over 3. I don't want to put it in decimal sense. That is not the final answer. Meters over second squared. That is meters per second squared. That is our acceleration. 5 over 3 meters per second squared. But we are not looking for acceleration, we are looking for final velocity. So we can actually use this question 1 now to solve for final velocity. V1 equals to U1, which is 0 plus A is 5 over 3 meters per second squared times T, that is 12 seconds, times 12 seconds. Okay, V1 is equal to 5 times 12 will give us 60. Remember, 0 is gone. Then meters per second squared times second, the law of indices, this is raised to power 1, minus 2 plus 1 will give us minus 1 all over 3. So our V1 is equal to 60 over 3 will give us 20 meters per second. So this is the final velocity for the first stage. That's the final velocity for the first stage. That is, from our diagram you can see now that V1 is 20 meters per second, and that is the same as U2. So that is for the first stage. Then in the second stage, our U1, U2 for the second stage is the same as V1. It's the same as the final velocity for the first stage, that is 20 meters per second. Our S, as we can see, is 300 meters, that's the distance. The final velocity is what we are looking for, v2 is unknown. The acceleration also is unknown, but the time is the same, but because they said equal time interval, 12 seconds. So we follow the same process. S equals ut plus half at squared, and our S is 300 meters, equals U here is 20 meters per second, and our time is 12 seconds, plus half at squared. Our A is unknown and T is 12 seconds squared. Okay, we simplify further. We have 300 meters equals 20 times 12. We have 240 meters, because per second and second, this is raised power 1 minus 1 will go. So we have 240 meters plus 12 squared will give us 144 seconds squared times A all over 2. If you simplify this, 1 times A times 12 squared seconds squared, so all over 2. So we have this. We can then, okay, let us manage our space. So we can now say if 240 crosses the sign of equality, we are looking for A, we have 300 meters minus 240 meters to be equal to 2 divide 144 will give us 72 seconds squared times A. 300 minus 240 will give us 60 meters equals 72 seconds squared times A. Then to find A, you divide both sides by 72 seconds squared, 72 seconds squared. This will cancel this. So our A is what? 60 over 72 equals 5 over 6. I'm leaving it as a fraction because that's not the final answer. Meters per second squared. So that is the acceleration for the second stage. Then we use equation 1 to get the velocity, final velocity for the second stage. So v2 equals u2. What is our u2? 20 meters per second plus A is 5 over 6 meters per second square times T, that is 12 seconds. Okay, that is equal to 20 meters per second plus 5 times 12 will give us 60 per second squared times second, because this is 1 minus 2 will give us minus 1. So we have meters per second all over 6. 6 divided 60 is going to give us 10. So we have 20 meters per second plus 10 meters per second. Okay, and that's equal to 20 plus 10 will give us 30 meters per second. So the final velocity of the second stage is 30 meters per second. Final velocity of the second stage is the initial velocity of the third stage. So we've gotten the final velocity v1 of the first stage to be 20 meters per second. The final velocity of the second stage v2 to be 30 meters per second. And we saw the same for the third stage. So for the third stage, we use the same process. Remember, the final velocity initial velocity for the third stage u3 is the final for the second stage, and we got it as 30 meters per second. Okay, then the final velocity for the third stage is what we are looking for. The acceleration is what we don't know as well. The distance for this third stage is 180 meters, as we can see, 180 meters. By the time remains 12 seconds. Okay, so now let's look at this. Using the same process, S equals ut plus half at squared. Our S is 180 meters equals, our initial velocity here is 30 meters per second times our time is 12 seconds plus half times acceleration is unknown and our time is 12 seconds. Remember, it's 80 squared, you square it. So you have 180 meters equals 30 times 12 will give us 360 meters per second times second, minus 1 plus 1 will go, so it's 360 meters plus 12 squared will give us 144, the same thing we did before, second squared times a whole over 2. So 360 will cross the sign of equality to have 180 meters minus 360 meters equals 144 divided by 2 will give us 72 seconds squared times a. Okay, 180 minus 360 will of course give us a negative 180 meters equals 72 seconds squared times a. And we would want to make a the subject of formula because that is the unknown in the equation. So we divide both sides by 72 seconds squared so that a equals minus 180 meters all over 72 seconds squared. Okay, that is it. So our acceleration is going to be equal to, when this minus 180 over 72 is going to give us minus 5 over 2 meters per second squared. Okay, can we see that? So remember, I leave it in fraction because that's not the final answer. So we are going to use equation 1v3 equals u3 plus at. So we use that to solve that, so that our v3 is equal to, what's the initial velocity? 30 meters per second, 30 meters per second, plus acceleration is minus 5 over 2 meters per second squared times time, that is 12 seconds. This will give us 30 meters per second, okay, minus, plus times minus is minus 5 times 12, we have 60 meters per second, because per second square minus 2 plus 1 will give us minus 1 all over 2. So that is equal to 30 meters per second minus 60 over 2 will give us 30 meters per second. 30 minus 30 will give us 0 meters per second. So the final velocity at the third stage is 0 meters per second. What is this telling us? It's telling us that a body, so v1 is 20 meters per second, v2 is 30 meters per second, and v3 is 0 meters per second. So what it is telling us in this question is that the body started from rest. For first 12 seconds, it accelerated, and after 120 meters, it attained a speed of 20 meters per second. It accelerated again for 300 meters for the same 12 seconds and attained the speed of 30 meters per second. And after this, the body started decelerating. That's why we got a negative acceleration. When your acceleration is negative, it means it's deceleration. And then you see the final velocity became 0. So you can see how we are able to achieve that. So this is it. I told you, any of the equation, all you need to know is to find out which of the equation that has all the needed parameters and one unknown. That is the one you're going to use.